Today's Maths for Real is about mathematical formulae.
How you can use formulae to scuba dive.
To hire one of these classic cars.
And to organise the Loos, the massive music festival. But now for some formula facts.
Mathematical formulae tell you how two or more things are connected. For example, A equals pi r squared, which tells you how A, the area of a circle, is related to its radius. A is called the subject of the formula because it's on its own.
This next formula tells you how speed, s, is related to distance, d, and time, t. Now this time, s is the subject, so if you know d and t, you can work out s.
But what if you know s and t and you want to work out d? You need to make d the subject, and that means rearranging the formula. The correct rearrangement is this: d equals st. Stand by for the Maths for Real guide to rearranging formulae.
A fur mole.
What are you doing?
Wait, I've got another one for you, hang on. Oh, flame. I'm only doing what you said, you know.
What do you mean?
Rearranging formulae.
Stage struck. That's me.
Preparations are underway for one of the top music events of the year. I mean, it might look pretty empty now, but it's in a few days' time. This place will be buzzing with thousands of people here to enjoy the Leeds Festival. Well, thank you at the back.
For 3 days every August, Temple Newsome is home to 50,000 music fans. They need all the facilities of a small town.
The organisers need to make sure there's enough food to eat, enough drink to drink, with all that food and drink, enough toilets. Ian, around here, you're the man that knows about toilets. So how on earth do you work out the number of toilets you need for an event like this?
Well, there's 4 factors that go into the number of toilets that we have on site. 1 is the number of people that are coming. 2 is the length of time that they'll be here. 3 is the number of men to the number of women. And 4 is guidance from the Health and Safety Executive.
So what exactly do these health and safety guidelines state?
They state that we need 1 water closet for every 100 women and 1 water closet for every 500 men. But of course for the men there's urinals as well.
Well, how come then, Ian? You know, if the women have more toilets, why is there always a queue for women's toilets?
I don't know, I suppose it must have something to do with women taking longer to go to the toilet than men.
Too true. Now for the maths. Here's how the organisers can use a formula to make sure there's enough toilets for the women. T is the number of toilets needed, and W is the number of women. To work out T, you divide W by 100, because, as Ian said, you need 1 loo for every 100 women. The festival is expecting 25,000 women, so divide 25,000 by 100, and the answer is 250. That's the minimum number of women's loos they'll need on site.
Well, let's say the number of toilets is fixed. What about if an event only hires 30 loos? How many women will that cater for? Now this time, the W is the unknown, so we need to make W the subject by rearranging the formula to get it on its own. And at the moment, it's divided by 100. So to eliminate this division, we need to do the inverse, which is the mathematical opposite, which is multiplying by 100. Remember, the key to rearranging formulae is whatever you do to one side, you must do to the other. But we can simplify this, because the hundreds on the right-hand side cancel themselves out. And I can remove the multiplication sign from the left-hand side, because 100 multiplied by t is the same as 100t. And to flip that round, W equals 100t. And if t equals 30, 100 times 30 is 3,000 women. So 30 loos would cater for 3,000 women.
I don't think so, JB.
All this toilet talk really made me desperate. I'm just going to go and find a loo.
Driving this little beauty is £140 per day, plus there's a charge of 60p per mile. And as you might expect, you can make that into a formula. C is the total cost. 140 is the daily hire rate in pounds, and 0.6 m is the charge per mile. Each mile, m, costs 60p. To keep the units the same, that's 0.6 pounds. C is the subject of the formula, which means that if I know m, I can work out C. Say I wanted to drive 100 miles. That means m is 100. 100 multiplied by 0.6 is 60. Add 140 gives a total cost of £200. But what if I already know C and want to find m? The mathematical task is to make m the subject of the formula, and that means getting m on its own. But which do I deal with first? Addition of 140 or multiplication by 0.6? When I knew the value of m, to find c, I multiplied m by 0.6 and then added all of that to 140. To make m the subject of the calculation, I need to unpick that, and that means working backwards. The last thing I did was add 140, so that's the first thing I'm going to deal with. The inverse of addition is subtraction, so subtract 140, remembering to do the same to both sides, and 140 minus 140 is 0. Next, deal with the multiplication by 0.6. The inverse is division by 0.6, but remember to divide the whole of the left-hand side, not just part of it. The 0.6's on the right-hand side cancel, leaving c minus 140, all divided by 0.6 equals m. Or flip it around to read m equals c minus 140 divided by 0.6. So, if I've got £175 to spend, how many miles can I go?
The time is upon us where Katie and I have to do some maths for real.
We're both going to answer the same question, but only one of us will do it correctly. The other will make a deliberate mistake, which you have to spot.
So you decide, do you tick it or trash it? Now, F equals 9/5 C plus 32. Now, this formula connects the temperature in degrees Fahrenheit, F, to the temperature in Celsius, C. Now, make C the subject of the formula. Pens ready? Good. Go.
F equals 9/5 C plus 32. Make C the subject of the formula. I started by subtracting 32 from each side of the formula. So I'm left with just 9/5 C on the right-hand side. To deal with the 5, I did the inverse of dividing by 5, which is multiplying by 5, remembering to do the same to both sides. These cancel. To deal with the 9, I did the inverse of multiplying by 9, which is dividing by 9. Cancelling the 9's and removing the multiplication sign, I ended up with this. Then I flipped it around so that C was on the left-hand side.
I also started by subtracting 32 from each side of the formula. And I also multiplied both sides by 5, which I wrote like this. The brackets mean that everything inside is multiplied by the number outside. And these 5's cancel. Then I divided everything on both sides by 9. After cancelling again, I ended up with this. Then I flipped it around so that C was on the left-hand side. So whose working should you tick and who should you trash?
Did Jamie make the mistake?
Or did Katie?
It was me that made the mistake. I was right to start by subtracting 32 from both sides. And I was right to multiply by 5 and divide by 9. But my mistake was here. I've only worked on the F and ignored the 32, when I should have multiplied the whole of the left-hand side by 5 and divided all of it by 9.
That's what these brackets mean. They tell you to multiply everything inside them by 5. And this line means you divide everything by 9.
The world record for holding your breath underwater is over 13 minutes.
I think I managed about 13 seconds.
To explore the underwater world for any decent length of time, scuba divers use tanks of compressed air. Now, to make sure they get back to the surface alive, they need to know how quickly they're using the air up. So, in the safety of an indoor pool, I'm working out my consumption rate. That's how much air I use up underwater every minute. The formula I'm using is this. C equals O minus F all over T. C is the consumption rate per minute, that's what I'm trying to work out. O is the original amount of air in my tank. F is the final amount of air in my tank. And T is the time underwater in minutes.
So Sally, how did I do?
Well, you started off with 2,000 litres of air. You finished up with 1,900, which means you used 100 litres in 5 minutes. So if you take 100 and divide it by 5, that means your consumption rate for 1 minute was 20 litres.
So why is this formula useful for diving?
Well, if you're planning a dive in the ocean, for example, for a certain length of time, then you want to make sure you've got enough air in your tank.
I can see that. So if I know my consumption rate C, and I know my air at the beginning, O, and at the time I'll be diving, the only thing I won't know is F.
That's right, and you always want to make sure that F is more than 0.
To work out F, I need to make it the subject of the formula. The question is, what do I do first? When C was the subject, and I knew F, I first subtracted F from O, and then divided by T. The key to rearranging is to work backwards. The last thing I did was divide by T, so this is the first thing I'll deal with.
The inverse of dividing by T is multiplying by T. Now remember to do the same to both sides. The T's on the right hand side cancel, so the brackets disappear. And with formulae, you don't need a multiplication sign.
So you're left with T multiplied by C equals O minus F. But what now? If I want F on its own, it's the O I've got to deal with, which means subtracting O from both sides.
O minus O is 0, leaving us with F on its own, but it's negative F.
The subject of the formula should always be positive, so there's a bit more rearranging to be done. The correct rearrangement is F equals O minus CT. That's been a long time coming. I can finally work out if I have enough air for my dive. Now, the question I'll leave you with, how do I get from this to that? Come on, Sally, erase you.